Hello, my name is Georgia Stolle-McAllister, and I am the Post-Baccalaureate Research Fellow at the Maria Mitchell Observatory, and I'm also a member of the F4 collaboration. I've been working on analysis of optical follow-up of FRB host galaxies, and specifically I've been using integral field spectroscopy. So to start, just a real quick explanation of what this is. Integral field spectroscopy is where every pixel in an image is also a spectrum. So in an IFU data cube, you can look at individual spectra across the galaxy spatially. In the example here, I'm showing a section of the spectrum just centered on the H-alpha emission line, and you can see how it's stronger towards the center of the galaxy than over on the edges. So using an IFU data cube, we can measure properties of the galaxy and compare them with other observations. So these would be things like mass, star formation rate, and metallicities. But we can also compare these properties spatially across the galaxy itself. So for example, we could look and see if the FRB location stands out in any way from the rest of the galaxy. The sample I've been working with is a set of 3 host galaxies that have also been observed by ALMA and to assess their molecular gas content. And these galaxies are the hosts to FRB 180924, 181112, and 190102. So far, 2 of them have also been observed by the Very Large Telescope in Chile using the MUSE instrument, which is the optical integral field unit, or IFU. And so that's the data that I've been working with. For this short talk, I'm just going to look at one of the galaxies, 180924, where the FRB was really well localized using ASCAP, and you can see it there. It's shown there with the green ellipse. The strongest emission line that we detected was H-alpha. And since this is an IFU cube, I can fit a Gaussian to the H-alpha line in each spectrum from every spaxel independently. And then I use these to produce an H-alpha flux map, which is that first plot on the left. But I can also calculate kinematic maps. So there's the middle one here is the velocity, and then there's also velocity dispersion. And both of these look pretty typical for edge-on rotation. But the other power of an IFU observation is that I can calculate the star formation rate or the metallicity or other properties over the whole galaxy and also just in the few spaxels right around the FRB location, and in order to see how that location maybe compares with the rest of the galaxy. And finally, we can also take this information, so this H-alpha flux map, and compare it to other observations. I've got here three observations of host galaxy 180924. The first being this H-alpha flux from VLT MUSE, which you can also then turn into a star formation rate. The second image is from Hubble in the near infrared, so this traces dust in the galaxy. And I smoothed the original image, and this starts to bring out the spiral arms a little bit. You should go see the talk by Alexandra Mannings to learn more about this. And then finally, we also have an image from ALMA of the CO emission in order to assess the molecular gas content of the galaxy. So you can see that the information we get from the emission lines from the IFU observations really complements all the other follow-up observations, and altogether, they give a more complete multi-wavelength picture of the galaxy and also provide more details on the nature of the FRB location in particular.